And good evening, everybody, and welcome to the final night of this week of Online Prep Live from the ACT and Kaplan. I certainly hope you've been enjoying these last 4 days, well, including today, the 4 days of great ACT instruction. My name is Arthur. If you were joining us earlier this week, you saw me on Tuesday during the math session, and I'm very happy to see many familiar names in the chat this evening as we wrap up tonight looking at the ACT science test. I see Jenny said, Arthur is lit. I've heard of that expression before. I'm not 100% sure what that means, but I'm going to take that as a compliment. Anyway, it's so good to see all of you here tonight as you're all logging in, getting settled for tonight's look at the ACT science test. I am joined tonight by a all-star team of Kaplan ACT experts. I've got Boris, I've got Heather, Beth, Farah, and Stephanie all joining in tonight, and Katie, sorry, I forgot Katie, all joining in tonight to help out with any questions that you might have. You can bring those questions up into the chat section that you see directly to my right. Directly to your right, and if you have any questions, please bring them up. Any questions at all, please don't hesitate to ask us. That's one of the great things about the online classes, the live online environment. You don't have to wait for me to pause. You don't have to wait and be hesitant and be like, hey, I have a question, but I'm not sure if I should ask this. Is it okay? Just ask the question, and one of our many ACT experts will be able to answer your questions in a very personalized manner. So that's one of the great things about the online class. One other quick logistical note, toward the bottom right corner of this video pod, just like how YouTube is, if you want to change the video setting a little bit, when we get into the slides and the text that you see in the slides, if anything's unclear, you can change the setting there. But for the most part, you can just sort of leave it as the default, and you should be perfectly good to go. Great to be with you all today. I'm very excited as we wrap up day 4 of the ACT Kaplan Online Prep Live Week. Let's take a look at what we're going to cover tonight in the ACT Science Test. And I'm not going to read these things to you right now. I want you to read them. And I want you then to first tell me, what do you notice is kind of missing here? When you read these 4 learning objectives for tonight's session, there's something that you might think, well, wait a minute, shouldn't we also be covering this? Shouldn't we also be covering this? Shouldn't we also be covering this? Tell me some of the responses you might be coming up with in terms of like the things that you think the ACT science test would normally include, but we're not including them tonight because honestly, some of these things that you may be thinking are not included at all. Some of those things you might be thinking things like, well, wait a minute, where's like the biology? Wait a minute, where's like the physics? Where's the math formulas or calculations that are needed to answer some of those physics questions? Where's the knowledge of science? Where is like the science facts and figures and things to memorize? Well, guess what, folks? The ACT science test is not about memorizing a whole bunch of facts and memorizing a bunch of statistics or types of animals or, various species of animals or like the human anatomy and like the physiology and things like that. It's not about that at all. In fact, as you look at tonight's learning objectives, here are the things we're going to build on. Looking at a passage, a roadmap to help you locate important references. Recognizing the application of the scientific method. Okay, so there's a little bit of science involved by the scientific method. Type in the chat, when did you first learn the scientific method? I'm going to take a wild guess. Maybe for some of you, you learned the scientific method even before high school, right? This is like something the first time you did, maybe like a science experiment back in the day in like elementary school when you're like making your first volcano or whatever, right? So you learn the scientific method way before you learn about any like deep science knowledge. But we're going to look at the applications of the scientific method. We're going to look at the how to analyze values that are being displayed in charts, graphs, and tables, lots of different visual data forms. And then lastly, how to read axes, units, and values quickly and accurately. So again, What we're missing here is like physics or chemistry. We're not missing that at all, because thankfully on the ACT, you don't need a lot of science knowledge. So what is the ACT science test about? That's what we're going to look at tonight. So just as a quick thing before we get started, remember the science test is always the fourth test. So we did these in order, right? For those of you with us on Monday night, you saw Eli cover the English test. I was with you guys on Tuesday for the math test, and then Eli was back yesterday for the reading test, and tonight we're wrapping up with the science test. And one other quick note, the ACT essay is optional, so you are not required to complete the ACT essay test. So those are the 5 ACT tests. The ACT is the science test is 35 minutes long, and you'll have 40 questions distributed over 7 passages. So if you look at those numbers in particular, 35 minutes long, distributed over 7 passages, you are looking at an average of about 5 minutes to spend on each passage. It's not a lot of time, and as you've already seen, maybe you experienced it a little bit on the math test or on the reading test or on the English test, keeping time is a big part to your success on the ACT. And being successful on the ACT is not just about having some kind of random number to add to your resume or to your college application, but basically a strong ACT score means that you are ready for college. The ACT is meant to be a college readiness test. You want to show those schools that you are deserving of a spot at those top schools that you're looking for. So in order to master the ACT, you will need to think about timing. 5 minutes for each passage, not a lot of time, but we'll see how we can get through that as quickly as possible. Give me a comment in the chat if that sounds good. If you're like, yeah, Arthur, timing was like one of my biggest concerns, or man, how am I supposed to get through those passages in such little time? 5 minutes doesn't seem like a lot of time. If you've seen practice ACT questions in the past, you may be thinking that right now. That's what we're going to look at tonight. We start by looking at again, what is ACT science all about? So we do have these different types of science passages. And again, stuff that you've seen at some point in your lives. Biology, chemistry, earth science, space science, physics. So all the passages will fall under one of these 5 general categories under science. And what you want to remember also is that every question can be answered using only the information from the passage. And that's a big thing, right? Because sometimes, and I think for those of you, I know I saw a lot of people in the chat at the very beginning saying like, yeah, I actually feel pretty comfortable with science. That's honestly not something to worry about per se, but something just to think about. Don't rely on outside knowledge. Don't say to yourself, well, the answer is A, because I vaguely remember that 2 years ago when I was studying chemistry. No, no, no. The answer to every question should be answered with information that's just in the passage. So keep that in mind. And then the ACT science test, is basically asking you, how well can you do these things? First, those experiment passages, right? Like experiment 1, the author did this, the author did this, the author did this. Can you identify 3 important components? The purpose, the method, and the results. If you can take every experiment and basically just boil it down to those 3 elements, you have already gotten through that passage about that experiment quickly and effectively. It's also testing you on how well you can look at graphs and tables and charts and find and identify variables and find patterns. Because that's, again, another big thing about the ACT science test. It's not necessarily asking you what's the exact number that you can predict from like an experiment happening now, like what would that result be 5 years from now, 10 years from now? But it's asking you, hey, what's the general trend? Do numbers go up? Do numbers go down? Things like that. And lastly, just simply applying scientific reasoning. Thinking like a scientist. I saw one of our ACT experts mention that in the chat also at the very beginning, right? Like, it's not so much about science knowledge, it's simply this. Can you think like a scientist. And I'm not talking about like one of those genius scientists who work in a lab all day with those funny glasses. I'm talking about just thinking methodically, thinking like an expert. Not being an expert, but simply thinking like an expert. Because the idea is, with a great science score, many of you are going to be using your ACT science score or your success on the ACT science test to lead you maybe to a science-related career or something maybe STEM-related. And that's what a lot of those careers, whether it's in the sciences, whether it's in math or technology of some sort, a lot of like these questions are all about showing how well can you think through problems, how well can you reason out answers. That's ultimately what ACT science is all about. And that's stuff that you can learn and you can practice and you can become better at. So, and of course, what you're participating in tonight is just one little sample session, but our full ACT Kaplan online prep live program will feature every single skill needed to succeed on the ACT science test. Okay. And yes, I love that comment, I think, Leighton, that you put into the chat just a moment ago. Science itself doesn't necessarily have anything to do with biology or physics. Critical thinking, experimental understanding. Leighton, you are already thinking like a scientist. You are already thinking like an ACT science expert. You're already well on the road to success there. Great work already. So the first skill we're going to take a look at here deals with active reading and effective note-taking. So again, I don't want to keep hammering this point home, but it's an important thing to note, right? When you're reading those experiments the first time, I don't know about you guys, but I know sometimes when I'm reading something that's really long and maybe not to me the most personally interesting thing, when I read the thing, I'm just like reading and reading and reading and reading. And when I get to the end, I'm like, what did I just read? And then what happens? I got to read the whole thing again. So instead of wasting time by reading something once, twice, and then a third time, as you're reading this experiment or as you're reading a science passage, employ these techniques of active reading and effective note-taking. The first thing is about making the first benefit is to make the search for passage details easy for yourself. So here's what we mean by active reading. As you're reading the passage, not after, not like once you're done, but as you're reading, if you notice important themes, if you notice important phrases, not the super specific stuff, but the general ideas or the general thoughts that they're bringing up in a paragraph or within the passage. Summarize any new content in the margin in a few keywords. I would honestly say like 10 words or less. Even 10 words might be a lot, right? So just a few notes in the margins. And Diana, yeah, exactly. Main idea topics and not even the small details. Like, well, I guess small details, maybe, Diana, this is what you mean. Like, just like, rather than writing out the explicit details that are being mentioned, just be like, oh, this is the thing about the stars. This is the thing about, like, temperature of stars. You don't write out each temperature in the margin because that stuff's already in the passage. But this is about helping you summarize the information more effectively. And this will make answering the questions both faster and easier because, folks, let's face it, where do you get the points? Do you get the points for reading the passage for memorization and memorizing every single detail? Or do you get points for answering those questions? I think we all know the answer to that. We still need to read the passage, but you don't put your energy into trying to memorize every single thing. Instead, you put your energy towards understanding what the passage is, so when you get to those questions, hopefully those questions become easier and easier and easier, and that's going to lead you to success. Second point, and again, kind of piggybacking off, Diana, what you said before, focusing on the overall main idea and the author's purpose. So as you're reading the passage, especially towards the beginning, ask yourself a couple of questions. For instance, what's the point? of the paragraph that I'm reading. Like, what's the big theme that the authors bring up in this paragraph? And then you may ask yourself, okay, well, they're bringing up this. How might they test me on this particular concept? How might they test me about the thing that I just read? Keep it simple, keep it basic, but these are the sort of questions that you think through, just as how a scientist would if they're reading about an experiment. And then mark up the actual passage text selectively. So you can underline or circle just one or two things in any given paragraph. I don't want you to underline like entire sentences, because you can actually tell me in the chat if you've ever done this, right? You underline the first sentence because like, oh, that first sentence is pretty important. Then you end up underlining the second sentence, oh, that's one's important too. And then the third sentence, yeah, that's really important. And the fourth sentence, and all of a sudden, what happens? What happens? You've underlined the whole paragraph, which means you're saying everything's important. And in reality, you're actually saying nothing's important. Nothing stands out more than anything else. So then it almost becomes this big waste of underlining the entire paragraph. So only underline or only mark like one or two things. Because if everything gets circled or everything gets underlined or marked up, again, nothing stands out. So just mark up one or two things in a paragraph. So let's take a look at an example of an ACT science passage. This may not be the most interesting thing you'll ever read in your lifetimes, but we can still navigate through this and get through the questions and show off our college readiness skills. Let's take a look at that first paragraph. Blood pressure, the force that blood exerts on the vessels of the cardiovascular system, can be measured using a and we're going to call it SMM, all right, SMM, and a stethoscope. The SMM consists of an inflatable arm cuff, a pressure gauge, and an inflation pump. Stop right here. As we've already gotten to the end of this first paragraph, you may have already noticed, like the big theme. Type that out into the chat. 8 words or less. Type it quick. What's the main point of this first paragraph? What is the author's most important thing in relating this paragraph? Give you a moment just to jot that down into the chat. Type it out into the chat so we can compare notes, see what kind of answers that you guys come up with. But again, in just a few words, what is that first paragraph really about? What is that first paragraph really about? Yeah, I'm seeing some great answers here. How blood pressure is measured, right? What they use to measure blood pressure. All of these great responses I'm seeing. Jacques, blood pressure can be measured with 2 instruments, the SMM thing and the stethoscope thing, right? We're also seeing blood pressure and SMM, how it's measured. Awesome. So if you jotted something like this down for paragraph 1, blood pressure measured with, I wouldn't even recommend necessarily writing out the whole thing, just like the 2 things, right? SMM, stethoscope, measured with 2 instruments. Awesome. Now, if you take a look at paragraph 2, this one's a little bit longer. This one's a little bit more intense. But again, as I'm reading this out loud, if you start noticing the most important things, take a quick mental note, and you can type those into the chat even as we're going through it. Let's take a look at that second paragraph. In order to take a measurement, the armband is placed around a subject's arm while the user listens to an artery in the forearm of the stethoscope. Although the normal flow of blood has no sound, the sound of the subject's pulse disappears when the arm cuff is tightened and the artery becomes fully compressed. After the pulse disappears, the user slowly deflates the arm cuff. As blood starts to squirt through the partially compressed artery, the user will hear sound and take a reading on the pressure gauge of the SMM. I'm actually going to stop right here. I'm a few sentences into the second paragraph, and already there's probably certain themes, certain big things that are being measured here. And I see a couple of great responses here. For instance, like, how do they take the measurement? Like, what's the process? How to, Shikhar, yeah, how to exactly measure blood from the patient's hand. Absolutely. How the stethoscope functions. Oh, awesome, guys. So paragraph 2, we're starting off by just talking about like how you actually use the instrument to measure, to take the measurement of blood pressure. Now let's go on from there. This pressure is called the systolic pressure, SP, with a normal resting value of 120 or less. When the squirting sound disappears and blood flow returns to normal, a second pressure reading is taken. This is called the diastolic pressure, DP, with a normal resting value of 80 or less. So wrap up the last part of that second paragraph. Again, in just a few words. What new information, what new content is being brought up in this particular paragraph? So first we started with just the process of taking blood pressure. Now, what have they added on in this particular, towards the end of this particular paragraph? So the process, and noticing the two types of pressures that are mentioned here. The new content here, systolic pressure, diastolic pressure. So systolic pressure, they tell us normal rating, normal value of 120, diastolic pressure, normal value of 80. So you might want to add that to your notes for paragraph 2. Blood pressure process, how do they do it? They listen to the arm. Systolic pressure should be less than or equal to 120. Diastolic pressure should be less than or equal to 80. So far, so good. Awesome. Let's take a look at the third paragraph. Third paragraph is pretty short. So here's what, so again, as you're reading this third paragraph, type into the chat what you notice the main point here is. Heart rate, the number of times a heart beats per minute, can be measured by putting a hand over the chest and counting the number of beats in 1 minute. A normal resting heart rate is between 60 and 100 beats per minute. This should be pretty quick, folks, right? What's the main point of paragraph 3? What is the main thing that the author is trying to convey here in this third paragraph? This third paragraph. Yeah, simply about heart rate, right? How to measure heart rates. Heart rate is measured in beats per minute. 60 to 100 is the norm. How you measure it, you know, like counting the number of beats in 1 minute. So in 1 minute, how many beats are done? Boom, 60 to 100. And then the fourth paragraph. I'm not even going to read this paragraph out loud at first. Type into the chat. If paragraph 3 was about heart rate and how it's measured and what's considered a normal heart rate, what's paragraph 4 about? There are probably like 3 things that paragraph 4 is about, just like how there are 3 things about what paragraph 3 is about. What are the most important things that are being mentioned here in paragraph 4? Breathing rates, how it's measured, and what's considered normal. There it is. Breathing rate, how it's measured, and what's considered normal. Awesome so far. And then we take a look at the 5th paragraph. To test the effects of different activities on the cardiovascular system, a student was administered various tests of cardiovascular function. First, the student's measurements were taken and recorded to establish baseline values. Next, the student ran on a treadmill for 15 minutes and the measurements were taken again. Finally, the student meditated for 10 minutes while listening to soothing music, and her measurements were taken afterward. The results are summarized in table 1. So again, as you're reading through this, if you notice, what's the main point of paragraph 5? What is the author now bringing up here that's a little bit different than what we saw in the earlier paragraphs here? Notice the tone changes, something changes a little bit in this 5th paragraph. What's the new thing that's being brought up here in this 5th paragraph? And I think I see some comments here coming in about like, okay, there were some activities going on, right? Like here, paragraph 5 is actually kind of like the real experiment part, right? Paragraphs 1 through 4 were a little bit more of like the background, like what did they accomplish, what did they try to do, right? But paragraph 5 is now bringing up like taking notes on an experiment, recording certain data, recording how, you know, like what the, like kind of like the normal heart rate and systolic, diastolic pressures, heart rate, breathing rate, things like that. But then also seeing what happens when they do certain activities. So that's paragraph 5. And then lastly, the table. Now, Are you going to sit there and try to memorize all those numbers and all those different data points about, what's the diastolic pressure when someone has been, after someone's been on the treadmill for 15 minutes? What's the heart rate after 10 minutes of meditation? Are you really going to do that on the test day? Of course not. But in general, what's the point of the table? If paragraph 5 was to outline what the experiment was and what they recorded, what's the point of table 1? The measurements, the data, what they found out. You don't care about the actual numbers themselves. But but if you notice here, again, just, hey, 3 different moments, right? Baseline, after 15 minutes on the treadmill, and then after 10 minutes of just soothing music and meditation. So the table here shows the results of that experiment. Great stuff so far breaking this down. And I know this might seem like it takes a little bit more time, but that's because we're doing this together as a group the first time. When you're doing this on your own, this will take a lot less time because you'll be able to literally pull out like the 1 or 2 sentences that you care most about in this passage. So now let's take a look at the questions. Take a look at number 1. And by the way, as we go through these questions, if you click on the section that says poll to the right side of your screen, you can select which answer you think is the correct one, and then we'll go and you'll see. So click on the answer that you think is correct as we go over this together. Take a look at number 1. Which of the following can be measured with no instruments other than a watch? So let's not try to reread the entire passage or try to reread every single word in that in those paragraphs. But instead, think about this. It's saying can be measured with no instruments other than a watch. Well, what is a watch good for? What is a watch used for? Watch is used for time. So if you need to think back about what that passage was saying about time, what were the things that can be measured by just looking at time? No instruments other than a watch. No instruments other than just measuring time. And if you look at those choices, again, get your answer into the poll if you have it. But again, think about which of those things, heart rate, breathing rate, blood pressure, or heart rate and breathing rate, which of those choices outlines the ones that you're just using a watch for. And if you remember, what was it? It was about both the heart rate and the breathing rate. Choice D is your correct answer. Nicely done, folks. Heart rate and breathing rate were both measured by number of beats per minute. So I see a few of you folks put down choice B, breathing rate only, but not just breathing rate, but heart rate. Now, if you take a quick look at choice C, blood pressure only. What's the problem with choice C? When the question says which of the following can be measured with no instruments other than a watch, what's the problem with choice C? To say blood pressure only? Wait a minute. Do we measure blood pressure with just a watch? Or do we need other stuff to help us measure blood pressure? And that, if you remember, was where? Where did we talk about that in this passage? And we talked about that at the very beginning in the first paragraph, using the stethoscope and that SMM thing that I'm going to not even care about how it's pronounced, like those instruments there. Good. So Diana's requesting first star of the night. I'm going to do you all one better. I am going to do a circle or a half circle of stars. Come and grab your stars, everybody, especially if you put down choice D for this one. Nice work here. Okay. All right, let's take a look at number 2. And again, poll is open. Put down your answer, the answer you think you have for this one. It can be inferred from the passage that with just a stethoscope, an experimenter listening to an artery in a normal living patient's forearm. Stop right here for a second. If you remember from this passage, where did they talk about using the stethoscope, listening to an artery? And they mentioned that, if you remember, yeah, it was like in the first part of paragraph 2, right? When they started talking about what? They talked about the process. So if you look at the process here, and I'll actually bring up, paragraph 2 again. So if you see paragraph 2, then again, in order to take a measurement, the armband is placed around the subject's arm while the user listens to an artery in the forearm with a stethoscope. Although the normal flow of blood has no sound, the sound of the subject's pulse disappears. So wait a minute. What's the thing that they're hearing here? Going back to that question. What are they hearing or not hearing? And I'm seeing most of you have put down choice F. They would be able to hear the pulse. Choice F is your correct answer. My favorite answer choice, honestly, I think is choice J, would hear various sounds depending on the circumstances, like sounds, like lots of different sounds, like the sound of like a text message going off, or the sound of your phone ringer, or the sound of the theme song of your favorite TV show. Like, what are they talking about here, right? So that one's a little bit weirder, I think, but definitely, right, in paragraph 2, they talk about the process of using the stethoscope and hearing the pulse. There you go. F is your correct answer. Very nice work on these first couple of questions that are about the background information about this experiment. Now, the next part we're going to look at here talks about the scientific method and understanding the 3 things to find in an experiment about the scientific method. So the first thing is the purpose. The purpose of the experiment is the main idea. So you may want to, so as you're reading through the experiment part, you notice how in this passage we kind of saw the shift into the experiment when they talk about the researcher is trying to do this. The purpose of the experiment is basically the main idea. So in order to know what the purpose is, ask yourself, what general concept are the researchers testing? What general concept? And what data are they trying to find out? The purpose of the experiment, honestly, is like, why are they doing this thing? Why did they do this experiment? So the purpose is kind of like the why. Why are they doing this experiment? The method is how the researchers set up the experiment. So you can ask yourself, what did the researchers keep constant, or what did they change? What process, what apparatus was used? Or even simpler, the method is how. How did they set this up? And then the results. What did the researchers, what did the people who are conducting the experiment, what did they find out? Ask yourself, hey, was there any difference between what they expected to find and what actually happened? Because I don't know about you folks, but I know when I did science experiments in high school, sometimes you expected something to happen and instead something else happened. Like, for instance, I expected no bubbling of the chemical liquids. But what actually happened? Bubbling of the chemical liquids. Uh-oh. Right? Like, sometimes that happens, right, in the real world with experiments. So that's what we mean by the results, right? Was there a difference between what they expected to find and what they actually found out? And the second part, and even the more important part, look for any clear trends, look for any outliers. Clear trends means, oh, does all the data go like in an upward or downward fashion? Or is there like, are there certain numbers that stick out a little bit more? So let's take a look at this experiment here. This is the same experiment that we just looked at, right? About the different activities on the cardiovascular system. So as we go through this, and we kind of went through this as we were going through the passage, but more explicitly, the purpose of this experiment, right? What was the purpose? Why did they do this experiment? If you can give that to me in like 8 words or less, type it into the chat. Again, this is the same experiment we saw earlier. What's the why here in this paragraph? Why did the student administer these tests? Why did the student conduct this experiment? And it's all about finding, hey, how does the heart stuff change, right? The first sentence, basically, right? To test the effects on different activities. Good. Does an activity change the cardiovascular system? Does an activity change the measurements of like the heart rate, the breathing rate, and all that stuff? So yeah, Rihanna, yeah, testing different activities in the cardiovascular system. Awesome. Now, what's the method? What did they use here? What was the process that they used here to test these different activities? And you can see that, you can probably see that actually a little bit even in that chart. There were 3 different things they did. One, they tested, first of all, just hanging out, right? The baseline. The baseline would just be, hey, you're just like chilling, you know, watching something on Amazon Prime, just like resting, you know, like just like chilling like baseline. And then the second part, right? They change the activity, right? Okay, now what if you're on a treadmill? And then after that, they recorded the data. And then after that, then they went into, what was it, like the meditation thing, soothing music, really calming down, and then recording that data. And if you look at that data, the results, I'll bring up the results. Again, don't worry so much. Don't worry so much about the specific numbers. But do you notice any trends here? Do you notice any trends here? Don't worry about the specifics here. But do you notice any trends about what happened when the person was running versus when the person was meditating and listening to soothing music? So we have the baseline, but what's the general trend of those numbers when the person is on the treadmill? And what's the general trend of those numbers when the person is doing meditation and listening to music? Again, without getting caught up in the specific numbers, if you notice, wait a minute, well, when the person's on the treadmill, those numbers tend to go up, especially the heart rate went up, right? And even the breathing rate went up a little bit, right? So the numbers generally go up, whereas after 10 minutes of meditation, what happens to those numbers? They're actually not just that they go down, but what? They go down even lower than if the person is just hanging out, just doing regular things. So there it is. I see a lot of comments now come in, increasing after the running, decreasing after meditation. Awesome. So you would note that when you're mapping through the experiment here. Okay. So again, so the purpose again, one more time, to determine if activities affects measured heart values, the method to test the baseline and then to test those activities, and then the results. Running gives you a higher heart and breath rate. Meditation gives you a lower heart and breath rate. And generally speaking, the blood pressure stays pretty much the same. It still went up a little bit, still went down a little bit, but stayed kind of very similar. Now let's take a look at the questions. Take a look at number 3. And again, the poll is open if you want to go through the choice and see which of those choices matches here. But if you notice here, even before you do that, there's one word in this question that makes it a little bit harder, that makes it a little bit more challenging. Do you see the one word in that question stem that makes this maybe a little bit more challenging, making you really forcing you to think through those answer choices just a little bit more? And you probably noticed it. It's the only word in this question stem with the big capital letters. Which of the following is not a valid criticism of the experimental setup? Absolutely, there it is. Whole slew of the word not coming down the chat. I love it. So which of those is not a good criticism of this setup? So whenever you have a question where it's like, okay, which one is not true? Well, that means 3 of those choices are true. You want the one that's not true, or in this case, not a valid criticism. So if you look at choice A says, as there was no mention of rest between activities, the reading after meditating may have been influenced by the impact of running on the treadmill. Whoa. Huh. That actually sounds kind of legit, right? It's like, oh, wait, yeah. What if they rested? Or what if they didn't rest? Wouldn't that affect the data? Wouldn't that affect the numbers? Choice A seems like it could be a pretty valid criticism of that. Take a look at choice B. The very act of administering the cardiovascular test with a restrictive apparatus may have had an effect on the student. Yep, that could be a legitimate criticism. Again, we're not saying that's the ultimate reason why this data might be wrong, but hey, it's a valid way of saying, look, this could affect your data, right? This could affect the way this data is being produced. So choice B looks like a valid criticism. Take a look at choice C. Listening to soothing music and meditating are actually two different activities that must be tested separately. Wait a minute. In this experiment, what are soothing music and meditating being used for here? What is the issue here with choice C when it says listening to soothing music and meditating are actually two different activities that must be tested separately? Would that change the data if they were tested separately? Does that obviously change the data? No. After running really hard, of course, the numbers would probably go up. And if you're doing something more calming, those numbers would probably go down. So choice C might seem a little bit weird here. So hold off on that for now and then take a quick look at choice D. Choice D says the measurement values were taken only at the end of the activity and may have shown a much greater range of values during the activity. Is that a legitimate criticism? Could that be a valid criticism? The measurement values were taken only at the end of the activity? Well, wait a minute. Maybe if you take their heart pressure, their heart rate and their breathing rate, like while they're doing the activity, well, then that might have actually made the numbers actually go way up. Think about it. Like if you're taking like someone's blood pressure like while they're running versus after they're running, maybe the measurement while they're running might actually go way up. And I think I see a lot of people putting down choice C as the correct answer. Choice C is the one that's not a valid criticism of the experimental setup because, again, that's not what the experiment is really trying to test. So that's not something that you can actually criticize about saying soothing music and meditating are two different activities. They're both these calming activities. Great work on this one, folks. Let's take a look at another key skill for these ACT science questions, and that talks about figure interpretation, looking at the different variables and units and trends in tables and graphs and charts. So the first thing, always note the variables. The variables of a table are what can change. Like, so for instance, in that last example, the blood pressure can change. The heart rate, the breathing rate can change. The first column is usually what's called the independent variable. If you have like another way of expressing that, type that into the chat. Like, what does that mean when something is the independent variable? Type that in just to see if we can recall our skills about science and science experiments. You might remember way back when you were first doing science experiments about like the independent versus the dependent variable. What's the independent variable? The independent variable, if you recall, was the thing that we can change, right? Like we can change maybe like, oh, the temperature inside like a room. Or we can change like how many more particles go into this test tube. Those are the things that we can change. So the first column is usually the things that we change. And another way of putting that, honestly, is, yeah, independent variable doesn't rely on something else because that's the thing that we control. Exactly, Derek. You took the words right out of my mouth. Controlled by the scientist. Perfect. Independent variable is what's controlled by the scientist. And then overall, the table is showing the relationships between the variables. Like, for instance, if the scientist controlled one of the variables, there are some other things that can get influenced. Exactly, Jasmine. So the independent variable is not influenced by itself, is not influenced by the other factors. The other factors are influenced by the independent variable. Awesome. So that's the first thing to note, the variables of the table. Secondly, the units. Be careful with this. Just take a quick look when you see those charts or those tables about like the units of measurement. Are the units listed directly on the table, or sometimes they are hidden within the passage. Lillian, I see what you did there. Dependent depends on the independent. That's a lot of dependence. Could the given units be confused? Like, for instance, and you can imagine, like, again, in terms of college readiness, one of the things you want to make sure that you're showing off your college readiness skills is that being able to read carefully, say, oh, this is in centimeters, but they want this in like inches, or instead of meters, they want this in feet. Oh, they gave me the conversion. I need to remember to use the conversion. I think at some point, I think we've all made that mistake at some point. Like, the answer is choice C, 3 centimeters. And you look at choice C and says, oh, wait a minute, that's at 3 feet. Right? Like that heartbreaking moment where you actually do the calculation, but you didn't note the unit. So be careful. Note what the unit is for all the data that's given. And then lastly, the trend. What patterns do you notice? Is data clearly going up? Is data clearly going down? And also, like, what should a new row of data be? Like, for instance, if you know for sure, like, going from, like, let's say, like, 20 degrees to 30 degrees to 40 degrees to 50 degrees, like, the dependent variable goes up, 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 then you can make the reasonable assumption that at 60 degrees, it'll keep going up. Like, it would be weird to say, well, at 60 degrees, now it's going to go down. Like, we don't know that from the information. But what we know is the clear trend in the data. So you'd use that clear trend to figure out what the next column should say or what the next row of data should say. So let's take a look at this one. Take a look at number 4. And again, the poll is open if you want to put down your answer for this one. How could the blood pressure of this student at rest be described? How could the blood pressure of this student at rest be described? Again, put your answer into the poll if you have it. But if you notice here, at rest is that first row. Rest is that first row. And you see those numbers are 118, 75, 74, 12. And then after 15 minutes on the treadmill, of course, with some athletic activity of some sort, those numbers go up. And then after 10 minutes of meditation, those numbers go down. So wait a minute. What do we notice here about these answer choices? Talking about systolic pressure and diastolic pressure. Are they higher than normal? Are they lower than normal? Are they normal? And I see a lot of people putting answer choice H into the poll. H is your correct answer. Both systolic and diastolic pressures were normal. Very nicely done. Good. So here's the thing, right? In this table, do we have any specific data that shows us clearly, oh, it would be higher than normal? Well, based on what we have here, it looks like, again, when you're doing athletic activity, the systolic pressure goes higher than the baseline. And when you're doing meditation, the systolic pressure is lower than you're at the baseline. That seems like normal data, and choice A says that both of those are normal. Nicely done, folks. Let's take a look at number 5. And again, poll is open for this one. Participating in which of the following activities for 30 minutes would not be predicted to result in an increased heart rate in beats per minute? So let's think about this. Again, poll is open if you have an answer for this one. The question is saying which would not be predicted to result in an increased heart rate in beats per minute. So type this into the chat. What are the sort of things that are going to lead to an increase in an increased heart rate in beats per minute? What are the sort of things? Keep it general, but what are some examples of things? Again, try not to look at the choices just yet. But what are the sort of things that make the heart rate go up? Again, using that data in the table, looking at what we've measured here. What are the sort of things that are going to make the heart rate go up? And we're going to see, like activities, athletic movements, aerobic activities, exercises, movement of some sort. Well, we want the one that's not going to give us an increased heart rate in beats per minute. And this one, you guys just killed this one. Awesome work here. Choice A for awesome. Choice A for not just 1 gold star, but 1 gigantic gold star. Awesome work on this one. So look at this again. How much of this is based on like knowing everything about science. Some of this is honestly just like science in the real world. Things you'd expect to already know at this point in your lives by being a living, breathing high school student who's taking science in high school. This is a great example of the kind of reasoning that you need to succeed on the ACT science test. Let's take a look at one more question here, number 6, based on this table. What conclusion can be drawn about the student after a period of exercise? So what do we know for sure here? What do we know for sure about a student after a period of exercise? Well, based on this table, after 15 minutes on the treadmill, the numbers go up, right? The numbers definitely go up. So here's the thing. Look at those answer choices for a second. Choice F, dangerously high heart rate after a period of exercise. Choice G, dangerously low heart rate after a period of exercise. Choice H, normal range for heart rate. Do we know anything about what's considered a dangerously high heart rate or a dangerously low heart rate or a normal range for heart rate after a period of exercise based on the table itself? Do we have a lot of information about that? Actually, in this, we don't. All we know is we have our baseline. We have the numbers certainly went up after a period of exercise. But here's the big problem, folks. Choice F talks about dangerously high. We don't know what it means to have a dangerously high or dangerously low or even the normal range after a period of exercise. So wait a minute, folks. What is your correct answer, everyone? I'm seeing a ton of people putting in choice J, and J is your correct answer. Very nicely done here, folks. And that is, I saw a request for this one, I don't know the exact color of a rosé gold star. I'll give you a rose-colored star, and I'll give you a gold star. How about that? And then that way we can just mix those two up together. I hope that's sufficient. That way you guys are getting not just one giant star, but you are getting 2 giant stars. Rose, I guess the new Apple iPhone has like a rosé gold color, but I don't have that particular color, so I'm not 100% sure of that color. And Diana, you asked a really great question. How am I supposed to know what's dangerous? I'm not a doctor. Well, the ACT certainly doesn't expect you to be a doctor, but the ACT would say, if you knew, the ACT passage would say a dangerously high heart rate would be in the range of like whatever the numbers would be, like 100 to 150 or blah, 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 right? Like the ACT passage would have to say that. Since the passage and the table doesn't say that, of course, that's why choice A is the answer. There's not enough information. Diana, I hope that makes sense. Let us know if you have any follow-up questions from that, but it's a great point you brought up. You don't need outside knowledge. If there's a question here that kind of says, wait, if I'm trying to answer this, I would need outside knowledge, and you didn't give me any knowledge that's helpful here, well, then look for the answer choice that's saying, you know what, there's not enough information. And that's why choice J is the correct answer here. All right, great work on this. Let's take a look at one more set of skills. We talked a little bit about variables of a chart or a graph. So as we saw before about variables of a table, specifically now about dealing with a chart or graph, the x-axis is usually the independent variable and the y-axis is usually the dependent variable. Again, the x-axis is the thing that we can change. The y-axis is the results of those changes. So overall, the graph always shows an x to y relationship. The units show how quickly each variable changes. So again, a couple things you want to look at when you're looking at charts and graphs. Take note of like what each marking means. Is each marking automatically changing by 1 unit? Maybe not. Maybe by 10 units. Maybe by 50 units. Maybe by 100 units. So just take a quick note of that. And then also, are those tick marks separated by non-standard amounts? So sometimes you may get something where, like, let's say like this, this was 0, and then this was like 5, and then over here would be something like 20. Right? Like they'll be spread out. So you may occasionally see something like that. Be careful when you see those. Just note those non-standard amounts or non-standard changes to the axes. Okay. And lastly, the trend. what general concept can we take away? Do the two things go up? Or maybe as one of those variables goes up, the other goes down. Or maybe as one of them goes down, the other goes up. So notice the relationship. Is there a direct relationship or an inverse relationship? And then also, what should the graph look like beyond the view? So for instance, if you said, well, for every 10 degrees, for every 10 degree in temperature increase, the color keeps changing more and more and more. Well, then at 60 degrees, 70 degrees, 80 degrees, even if it's not in the chart or graph, you can say, well, you know what? The color is still going to keep changing, or the amount of stuff is going to change. It's going to go up by the same amount, or go up or down by the same amount. So let's take a look at this example here. We have here solid materials are examined for their maximum solubility levels in water at various temperatures. We have a figure here showing the grams of solute for various chemical compounds in a saturated solution with 100 grams of H2O, which I think is water, right? Water solvent at temperatures between 0 degrees and 100 degrees Celsius. So they do give us one important thing. Solubility is measured by grams of solute in a saturated solution versus grams of solvent. Type into the chat real quick. What's the grams of solvent that's in this data? What's the thing that they're talking about here in terms of the grams of solvent in that data? And then, of course, if you see the chart there, if you see that chart there, we talk about solubility on the y-axis and temperature on the x-axis. So grams of solvent, yes, is the amount of water, right, per 100 grams of H2O. And we also see the other variable here about temperature. So our variables, and just to note here, looking at that chart, what's the independent variable and what's the dependent variable? We know what the two variables are, right? Temperature and solubility. But just to be clear, what's the independent variable and what's the dependent variable? What's the thing that the experimenter is changing, and what's the thing that's changing based on the other thing? So we know it's temperature and solubility for the variables, but just to make that extra note here, temperature is, there it is, temperature is the independent variable, and solubility is the dependent variable. So that's the variables. Now, in terms of the units, type this in if you notice it. What are the units that they're using for both of these variables? First, the independent variable dealing with temperature, and what's the unit of measurement for the dependent variable dealing with solubility? And there it is, degrees Celsius, and solubility measured as grams of solute per 100 grams of water, and then the trend. Again, don't worry about trying to calculate numbers, but what's the overall trend that you notice here in this figure? What's the overall trend that you notice here? Or what's the one big statement that you can make based on all of this kind of crazy looking data here in this figure? And I see a few folks are noticing it. Yeah, like it seems like, yeah, they're going upward, right? They're going upward, going positive. But here's the one thing to be noticing here. Are they all going upward? So I see a lot of you saying positive, a lot of saying upward, direct relationship. Are they all going direct? Are they all going direct? Not all of them. Most of them, right? Most of them are going up, right? So temperature and solubility are positively correlated for most substances. But just notice how there are like one or two examples here where as temperature increases, the solubility actually decreases. So that's why we just want to make sure they highlight the word most here. Most substances, the trend is a direct relationship, but in some of those, we do see one or two are going downward. Good. Very nicely done. Let's take a look at the questions here. Take a look at number 7. Poll is open on the right side if you want to try this one here. Which of the following solute shows the greatest increase in solubility as the temperature increases from 0 degrees to 100 degrees? So 0 degrees Celsius to 100 degrees Celsius. So notice here in this question, it's all the data, right? Going from 0 to 100, and we want the one that shows the greatest increase in solubility. So this is where a lot of like the stuff that you learn, not just, the stuff that you learn in high school is often related to each other. So for instance, a science question may have some sort of math things involved in it, right? So when you look at like the greatest increase for something, like what are you really looking for here? You're looking for the one where it kind of goes up the quickest. Give a bonus star if you know the term, the mathematical term, when you see it on a graph, when talking about like a line that goes up really fast, or how you measure that actual term. So it has something to do, kind of similar to the concept of what? Slope. There it is, steeper slope. You're looking for the one that has the biggest slope. And I think you guys have got this. I see a lot, pretty much everybody has put down choice D, KNO3, because that's the one that starts way down towards the bottom, right? And then by the time it's 100 degrees, is way up around 240. Awesome work, Alyssa, Celia. Awesome, noting steeper slope there. Good. Let's take a look at question number 8. Which type of solute, according to figure 1, has a lower solubility at higher temperatures? So here's the thing. This is where, again, noticing before how most, but not all of those compounds go up with a higher temperature. Here we're looking for a lower solubility at higher temperatures. So first of all, if you notice here, the ones that have a lower solubility at the higher temperatures, well, we're looking for the ones that have a negative slope. We're looking for the ones that go downward. Well, I see a couple of those that are going downward. For one, Na2SO4, and the other one down here, CeSO43. Well, wait a minute. That must be the thing that's making these have lower solubility, right? Because these are the only two that are going downward. And wait a minute, what's in common with these two things? What's in common with these two things? What's in common with these two things is that they both have SO4 in them. Well, wait a minute. Take a look at those choices now. And I think we're seeing it. Most of you guys are putting down choice H. Sulfates is the type of solute that has a lower solubility, because if something contains sulfate and SO4 in it, it produces a lower solubility. Awesome work on this one. I totally neglected. You guys definitely deserve gold stars on this question and on the previous question. So there it is, folks. I'm actually going to give you a little bonus here. I'm going to give you an example of a friendly gold star. That reminds me of like the Super Mario Brothers games. I don't know if you guys, well, I know there are like millions of like Super Mario Brothers games, but I remember like the old school Super Mario Brothers game where like you grab the star that's like bouncing around. The star looks really happy, and then once you grab it, you're like invincible for a few seconds. So not just gold stars, but invincibility stars. ACT excellence stars for all of you on that one. Nicely done. Let's take a look at a couple more questions here. Take a look at number 9. Which of the following compounds appears not to be soluble in water at 100 degrees Celsius? So we're looking for the one that's not going to be soluble at all. Well, at 100 degrees Celsius, we're looking for the one that's going to be not soluble. So wait a minute. If we're looking at this here, well, how do we know that something is going to be at 0 solubility at 100 degrees? Because we don't explicitly see something here that says 100 degrees temperature, 0 solubility. But you may notice here, wait a minute, towards the bottom of that figure, there is one particular compound where even before it hits 100 degrees, has already hit 0 here, and that is this one. And for those of you who have it, choice B is your correct answer here. Ce2SO43 is the one that's not going to be soluble because it's already not soluble even before it hits 100 degrees. And you notice the downward trend. So again, if we see this downward trend, it makes no sense. Like all of a sudden it's just magically going to go up. Of course not. That's our scientific reasoning skills at play here. And then let's take a look at one more example here. Approximately how many grams of NaNO3 could be dissolved at 25 grams of water at 90 degrees Celsius? So let's take a look at what we got here. We're looking for how many grams of NaNO3, so that's this compound right here, at 90 degrees, so somewhere in the middle. So type this into the chat. What do you notice is the approximate solubility here for 90 degrees at NaNO3? What's the approximate solubility here for NaNO3 at 90 degrees? And again, you can just sort of like just create the straight line here to kind of like say, oh, well, right around, right around NaNO3 is going to be kind of like right around here, right? So I see a lot of you folks saying, yeah, it looks like 160. And of course, one of those answer choices says 160. Here's what you want to be careful. What's the other part of this question saying? How many grams could be dissolved in 25 grams of water? Look back at that table one more time. Look back at that graph one more time. What is solubility being measured here in the figure as it pertains to water? What's solubility here in terms of water in this graph? And we're seeing a lot of responses. 100, right? 100 grams in the table. But now instead of 100 grams of water, we've only got 25 grams of water. How is 25 grams of water related to 100 grams of water? It's what? It's 1/4, David. I love it. I appreciate the honesty. You had that, like, I like to call it that light bulb moment. Like, oh man, now I got this. 25 grams of water is 1/4 of what we're looking for. So if at 100 grams of water, it's the solubility is 160 grams, well, wait a minute. At 25 grams of water, what's our answer going to be? And I'm seeing a lot of people changing their vote, which is okay, changing their vote. But yeah, choice G is your correct answer, 40 grams. Good. And yes, if look at the units. That's the important part. A lot of people, and honestly, you can let us know. I certainly have been guilty of this in the past. You almost overlook the units sometimes. You're like, well, I just care about the numbers, right? The 90 and the 160 and the 90 degrees and the NaNO3, and like that's the one that, and I see 160 grams. Look at those units to avoid making a silly mistake. And this kind of question is can be the difference between a solid ACT science score and a great ACT science score. Not by memorizing all these science concepts, but by understanding how a scientist thinks through information. And Stephanie, that's why we're so glad you're here, because lots of you, not just you, lots of folks initially when they look at that, they would miss that. So how do you prepare to avoid those sort of mistakes? Again, tonight was just an overview of the science test and giving you a few sample questions. I hope this was helpful and maybe even a little bit of fun. And certainly, as we saw on that last question, they can try to make us think more about a question. So you always want to think about what the question here is actually asking you for. A gold star for everybody. Unfortunately, I don't have a caricature. I don't have a shot of my face to put into the star because I think I saw a request for that. But I don't know. Maybe I can just look at the star. Okay, great. Great stuff here, folks. So as we wrap up over the next few minutes, just taking a quick look. Again, tonight was a sample, but we are super excited to bring to you all our new ACT Kaplan Online Prep Live program. It's basically an exclusive program that we're doing in conjunction with the ACT, or of course providing official practice test questions, official content, so you get access to access to official practice questions, practice tests, and you'll also get live instruction like what we've done here tonight. I hope you guys have enjoyed this so far. The live instruction to me is one of the best parts about learning, because it's always helpful when you're like listening to someone as they're speaking rather than sometimes, just reading something in a book or reading something online. So we have tons of live and on-demand instruction. The program will also give you personalized study plans. So for instance, maybe someone like David, for instance, might have fallen for that one science question about this particular topic. So David's study plan might say, hey, to make sure that you get the best improvement possible, you should check out these couple of things. Whereas maybe for like Stephanie, it'll say, hey, Stephanie, actually you missed these other questions, so you should work on these 3 things. That's when we met personalized study plans. No one gets the exact same study plan. Basically, the idea is that you're going to get a study plan that's based on your strengths and your areas of opportunity, the places where you can improve the most as quickly as possible. You'll also get access to Kaplan's best and brightest ACT experts. And me, they decided to let me do this tonight also. But anyway, but like I said before, my team of folks here tonight, Stephanie, Boris, Heather, Katie, Beth, Farah, Stephanie, all helping out here. And all of these folks will be part of the online prep live. I saw there were a lot of shout outs for yesterday's instructor, Eli. He is also going to be part of the online prep live program as well, doing a lot of these live online classes. So we're using our very best and brightest ACT experts. And this is something really exciting for us at Kaplan, that this is basically going to be a full test prep program at just $179 for a 6-month subscription. So in a lot of ways, it's not like you're signing up to take a class for one ACT. If you decide, look, I want to take like the October test, but then I also want to take maybe the December test, you can use that 6-month subscription to basically study for multiple ACT exams. So that's one of the great things about this program. And the other great thing is, if you do qualify for a fee waiver for the official ACT, you'll also get this program for free. It will be included with your ACT registration. Our ACT Online Prep Live program includes over 2,400 practice questions. You don't need to do every single one. I want to be clear about that. All right, I do not want you to do all 2,400 questions. Unless you feel up to it. But the idea is the personalized study plans will tell you which questions you need to work on, which things you want to work on the most, okay? In addition, you have 2 full-length ACT practice tests and 4 what we call short-form ACT diagnostic tests. You want to make sure that you're using those full-length practice tests to know what it's going to be like on test day. But let's face it, folks, with all the things that are going on in our lives, school and AP classes and honors classes and all of our extracurricular activities, maybe we don't have time to sit through an entire full-length practice test. That's what those 4 short-form tests are, because as that great internet meme says, ain't nobody got time for that, right? We don't have time to go through like 6 or 8 or 12 tests. Well, in this case, use one of those short-form tests to get you some targeted practice for the things that you need to work on the most. In addition, 450 digital flashcards. This is great for just studying on the go. Okay, 25 plus hours of instruction, and we're going to cover lots of different things. Every lesson that's designed to cover everything on the ACT. If we don't cover it in a lesson, it means it's not on the ACT. If it's covered in a lesson, it's on the ACT. In addition, we're going to have some great additional sessions, such as setting a good target score. Now, I know a lot of times people are like, my target score is a perfect score. But there are some factors that go into what the best score for you is. Obviously, you want to get as high a score as possible, but for the colleges, for the programs that you're applying to, they may want different types of scores. Like they may want a stronger score in the STEM categories, or maybe they want a stronger score in ELA. So we'll talk about those sort of things. Talk about how to manage your time, about managing test anxiety. And let's face it, folks, those sort of life skills aren't just relevant to the ACT. They're relevant for real life. I kind of want to make sure that like if I'm not teaching a session about time management, I want to watch a session about time management and see like what Boris or what Heather or what Stephanie might be talking about time management, because I know even as an adult sometimes time management can be something that's hard to that's hard sometimes to follow. So we'll have lots of great extra sessions like that. And also just, again, convenient live class times that, again, fit around your busy schedule. I honestly believe, I teach adults as well, not just high school students, but I also teach adults for other standardized tests. And like a lot of times, like, well, adults are the busy ones, right? Because adults are the ones that have jobs and stuff like that. But honestly, I think you guys are probably even busier than a lot of working adults who are studying for tests, because you've got school. Like, it almost seems like it never ends, right? Like, you've got school, but then when you get home from school, you've got the volleyball team practice. You've got time that you have to spend working on the yearbook or the school newspaper, and then you get home, and then you've got 3-4 hours of homework. It feels like it never ends. So that's another great part of this program. It's that we schedule classes that fit around your schedule. Okay. And again, if there's any class that you can't make for whatever reason, we do have on-demand recordings. It's kind of like Netflix or like HBO Go, where basically it's just like, I'm just going to search for a program today. You can search for an ACT lesson that's best for you. And you'll get, of course, detailed reports on how you're doing. And again, the things that you're strong on and the things you're not so strong on. So let me ask you this. Of course it makes sense to work on the things you're not so strong on, right? Because you want to improve. But then you're thinking, well, Arthur, do I need to work on the things that I'm also strong on? If you work on the things that right now you're pretty solid on, what does that do for you on test day? Think about that for a second. Type it into the chat if you can think of an answer. Why is it so important to work on things that you're already pretty good at? Because what that will do is, if there are things you're pretty good at, I don't want you to neglect them. You need to work on those things too, so that what happens? You save time, and you can bank that time on those harder questions. Because that's what people who study well for the ACT do. They not only work on the things that they feel a little bit weak on, but they also balance it out with the things they feel strong on, so that it saves them time. So instead of, for instance, I know we went over the math test on Tuesday. On average, about 1 minute per question. But if you can find the math questions that would only take you like 30 seconds or 20 seconds to answer, then you take those extra 30 seconds and then you move them to a harder question. So that's what we mean by working on both your strengths and your weaknesses. And again, basically, getting you ready for testing, because that's what we're all about at Kaplan, getting people ready for the ACT. So again, our top ACT experts, on-camera teachers such as myself, and again, folks like Boris, folks like Stephanie, folks like Heather, you will see them on camera as well, including off-camera teachers who will be working the chat pod, so that if you have any questions, even you're like, I don't feel comfortable asking this, I don't know if I should do this, type it in. We want you to make sure you get the most out of every class session that you're a part of. Okay? So I saw a lot of questions at the beginning. How do you sign up for this? How do you sign up for this program? Here's how to sign up. You go to the ACT test registration site at act.org. When you register for the ACT exam, you can add on basically this program, ACT Kaplan Online Prep Live. So if you're already registered for ACT, if you're like, wait, I already signed up for the ACT, does that mean I can't sign up? You can simply add on the Online Prep Live, and you don't have to register for a new test. So you basically, on the ACT website, when you register to take the test, you can add on the course, or if you're already registered, you can buy the Kaplan Online Prep Live program separately. Also, if you're already using ACT Online Prep, that's like sort of the base program that's already available on the ACT site. If you're already using that, but you want the online instruction, you want the extra practice questions, you want all the extra great resources, you can upgrade from the ACT Online Prep to ACT Kaplan Online Prep Live. And if you do it before the December ACT, it's only $75 to upgrade. Normally the upgrade fee would be $150, but for the first few months of this, we're actually taking 50% off the regular fee. It's a great opportunity to just add on more instruction at a very reasonable price. So keep that in mind as you think about when you're going to be taking the ACT exam. Okay? And with that, that wraps up for tonight. Couple things just before you guys go, though. Online Prep Live goes on sale tomorrow. So it may not be the exact same thing as like people lining up outside of an Apple store and trying to get the new iPhone, but we're also really excited about this. We anticipate we're going to have lots of folks that are going to be really interested in our program. Certainly hope that this week has been helpful. Chaitan, I'm sorry if I'm mispronouncing your name. Thank you so much for your feedback. I had a lot of fun over my 2 days I was teaching. I know Eli had tons of fun as well, teaching over on Monday and Wednesday as well. We're very glad you had the chance to experience this, and you can get more and more of this online prep instruction through our Online Prep Live program. Again, it goes on sale tomorrow, so check out the ACT website tomorrow. There's also a button directly below if you want to get more information about purchasing, if you want to get more details about the program itself. And otherwise, we hope to see you in a class very soon. We're going to be starting our ACT Kaplan Online Prep Live program this coming week. So it goes on sale this Friday, and then starting next week, we're going to be live online covering everything about the ACT with Kaplan. So we thank you so much for your participation. Thank you and a special kudos to those of you who are here all 4 days that got the most out of learning about the English test, the math test, the reading test, and of course tonight with the science test. One more time, big old gold star with, not only am I going to give you a gold star, folks, but I'm going to go really meta on you and give you a gold star wearing a crown of gold stars, because you all deserve that. We certainly hope to see you in one of our ACT Kaplan Online Prep Live classes very soon. But as you continue to study for the ACT, we want to, on behalf of everyone at Kaplan, on behalf of Boris and Heather, Beth, Farah, Katie, and Stephanie, again, my name is Arthur. It's been a pleasure to be with you tonight. Thank you all for tuning in. We certainly hope to see you soon in a class. Thank you all very much, and good luck. I saw one more request, so here we go. I can't believe I'm going to do this. That's the big thing, right, these days, the dab. Anyway, I hope that was epic. I hope that was lit, and I hope that was all those other words and expressions that I'm not cool enough to know. Anyway, thanks all so much. It's been my pleasure. We've had a lot of fun doing this, and we hope to see you even as early as starting this week when we go live with ACT Kaplan Online Prep Live. Take care, everyone. Have a great night.